Hello everybody, this is Steve with UpgradeYa. Today I'm going to walk you through the repair of an Antminer S17 Hashboard. In this particular case, this is where 20 and 44 ASICs were found as a result of an overheated BO circuit. This repair also applies for an Antminer S17 Pro Hashboard. Today we're going to be focusing on the bottom of the hashboard. This is also the portion of the hashboard that is at the air inlet, so if you are running air-cooled miners, this is where you're going to see your dirt, bugs, any buildup. I help operate a small mining operation, and I've seen the same failure on a number of my air-cooled units. I've seen 4 ASICs, 20 ASICs, 36 ASICs, 44 ASICs, etc. And if you notice, all of those have to do with the bottom section of the board. So in today's video, we are going to be discussing specifically the repairs of two sections. So right between ASICs 20 and 21 and 44 and 45. As you see me do my testing today, I am going to be focusing solely on the BO circuit. And here you can see the flow path, just an introductory for some of you. The flow path for the BO circuit starts at chip number 1 and runs all the way to chip 48 in series. So any break in this circuit and you're going to lose everything afterward. When performing live tests on the BO circuit, on your multimeter you should expect to see 0.001 volts. This is good. 1.8 volts is bad. Now don't be confused, because 1.8 volts is good for just about every other check with the exception of the clock circuit. This is my first tutorial video. I wanted to share some knowledge with everybody. If you find some benefit from this, please like, subscribe, leave a comment, provide some feedback so I can determine whether or not I'm going to do some more videos. Thank you, and let's start the repair. Okay, here we are at my testing station. As you can see, I have the Zeus Test Fixture there, and I'm making my connections. Good rule of thumb, always connect and remove. Connect your ground first, remove your ground last. My apologies for any of the jitteriness in this video. Alright, push the start button, watch it count up. Usually goes to about 5 to 6 seconds, and as you can see, I have 20 ASICs found. Alright, turn on your Flux or your multimeter to the voltage setting, DC volts. And up here in the corner, I'm testing the final endpoint signal for BO. So after chip 48, as you can see in the diagram here, that blue circle is that BO test point. So put your negative probe on the test point and your positive on the top of the heatsink. Click start on the test fixture, and here I got 1.829 volts. As I mentioned earlier, anything around 1.8 volts for the BO circuit is bad. Expected, what a BO circuit should be, is approximately 0.001, give or take a little bit. Okay, so now down here, traced out the path, and here's chip 20. Ignore those chip 28 and 29 markings on the drawing there. It's just a stock photo I've made for myself as a reference. So test the BO circuit between 20 and 21, hit start, and there you can see I got 0.001 volts. That tells me that everything up to that test point is good. So the following chip, 21, now I'm going to measure off the test point in between 21 and 22. Find the test point with your negative probe. As you can see there, what I'm hitting, that light blue BO circuit. Put your positive probe, hit test, and there you go, 1.818. So that tells me that's bad. So I'm good all the way up to that test point after 20, between 20 and 21, and this tells me that something after that test, for the test point in between that one and chip 21 to 22 is bad. Okay, here we are at my repair station. I wanted to give you a brief overview of where I'm going to be working next. Sorry everything's a little scattered, but here's an idea of some of the tools I'm going to be dealing with. If you do not have one of these microscopes, I highly recommend it. I wouldn't be able to perform this repair or others without it. Okay, here we are under the microscope. As you can see, I labeled the heat sinks 20 and 21 there. And again, apologies for this video and the jitteriness. The video from the microscope to my computer did not record very well. So here I am just trying to zoom in. As you can see, a close-up of the test points there on your left-hand side, and looking at the BO test point is there up top. So what I'm going to be doing here, as you can see, I have my same multimeter, my Flux, and this is the tracing out the path for the BO circuit from resistor 2044 there through the test point, and then you go up to here where there's no resistor, down through this resistor here, which is a 0 ohm resistor. This really serves not much of a purpose. Comes through those points and comes back down into chip 21. It does not go through resistor 1142 there. It goes to the right of it. So obviously first thing you want to do, usually I ultrasonic clean these, but just using I use some generic Walgreens 91% isopropyl alcohol. Do some cleaning here. Remove any excess debris, and then now I'm going to start doing some testing. More cleaning. Be careful when cleaning these. As you can see, resistor 2044 there looks pretty rough. So you don't want to brush this too hard to dislodge anything. So this is a part of the challenging point, is getting your needle in there for that negative probe and checking on the downstream side of that resistor, and basically I'm just checking continuity for that circuit. So that measured good. Now I'm going to try to get so that should be 0 ohms. Now I want to try to get on the upstream side of that resistor to verify if that resistor is bad. Getting in there and getting these points of these resistors is quite a challenge, especially this one, because without removing that heat sink, you really got to get in there at an angle. Me trying to do this under the microscope and not change the orientation of the board for you guys, it's a little bit of a challenge. Obviously you don't want to make contact with that heat sink as well. It might throw off your reading. So here I measure, this resistor is a 33 ohm resistor, and I did in fact measure 33 ohms. So that tells me that from chip 20 to that test point is good. Next we'll take a measurement for the following components. So from the test point to this next guy, as you can see, just following that track, you can kind of, looking at it, see where there might be some issues. I find that a lot in this situation, as I mentioned earlier. So I had issues trying to check that resistor there, so going through, I did not get continuity. So I measured an open on my multimeter. Now here I'm trying to check that track. And as you can see, there's corrosion built up on that. So I'm trying to get my needle in there, my probe, to get a good connection. And once again, clean up, clean up, clean up. A lot of times when I'm in here, I'll make a mess just because I start poking and scraping and removing some corrosion and debris from the other components. So this path right here measured bad. So I did not have continuity from resistor, from that point, which the resistor is not there, but resistor 1141 to resistor 1834 measured and open. The resistor measured bad as well too. Now I'm going to be removing this resistor, and I'm going to jumper around it. So this is a 0 ohm resistor. Basically is a short in the system. The only way I just look at that resistor as being almost like a fuse. If that circuit overheats, that fuse is going to open. So I put some flux where I'm going to be working and get my tweezers in there. And my soldering iron. Soldering iron set to 350 C. Just apply some side pressure with the tweezers. I just heated up one side. As you can see, that top pad is in pretty bad condition. I don't even bother replacing these resistors since they are 0 ohm. As you'll see here, I jumper around it. Next step is clean up the pads. Using my desoldering wick and my iron. Just get that thing clean. Here, in the beginning I was careful about not soaking up the solder from these other pads, but don't even bother. If you soak up from those other pads there that don't have any components, it's no big deal. And with this one, that really didn't have a whole lot of solder on it, but I do like to occasionally, if I'm in there after poking and prodding at these things with the probe, as you can see on that BO circuit on the left, there's a big indentation. Sometimes I like to clean them up just by dabbing them with the iron. Alright, now here, this is another set of tweezers I have. This is kind of a bad set with the tips pretty bad, so it's all bent up, but I use it as a scraper. I really should get an X-Acto knife and get in there and scrape this, but so I'm just trying to remove the corrosion, what's built up on that pad. As of right now, if I were to put solder on this, it would not take it. I have, working on some of these in the past, I have damaged a track by scraping too hard, so I'm usually kind of ginger with this. Some cleanup. So as you can see, I got a little bit of copper on that pad. Still not very much. Like I said, if I had an X-Acto knife, I think I'd be able to scrape it a little bit more, but be sure you do not scrape too hard to remove all the surface of what you're trying to make contact with. Scrape, scrape, scrape. It'd be a lot easier if I had a different tool. It's all about the tools, everybody. If you have the right tools, the job is a lot easier. Otherwise, you struggle like this. And once again, cleaning. So there you can see the top part of that track, the top part of that pad where it starts with the track. You can see that copper exposed. So removed a little bit there. It's probably already weak to begin with. Now I got a dry Q-tip. Soak up a little bit. Keep soaking. As you can see, I like to use the fine tip Q-tips rather than just the normal stubby ones that you might be used to clean your ears. Okay, apply a little flux to your working points. And I got a little bit of solder on that tip of that soldering iron. And really right now I'm just trying to get the solder, some of the solder to go on the pad. As you can see, I'm struggling quite a bit. Even with that pad up there, where 1141 would be, I have issues getting solder to stick. I've run into this problem repeatedly. Once again, with this circuit obviously overheated. Something caused the opens in this circuit, and that heating just does a number on everything. I think with this one, if I had a X-Acto knife, then I'd be able to scrape that a little bit better, and I'd probably get better contact with the copper there on the bottom. But anyway, this is ugly. This is a struggle. Lesson learned as you watch this. If I struggle this much with it now, I don't even bother. I just go around it. So I got a little bit of copper, or a little bit of solder to seat there on that middle. and try to get in and get a closer look. It's not pretty. Once again, sorry for the shaky video there. That video feed was not very good. I'll try to do better next time. Now here I'm gathering my jumper wire. So the wire I'm going to be using for this is actually a single strand that I pull from a ribbon cable. So I had an extra from another one. This is the ribbon cable that runs from the control board to the actual hashboard. So cut one of those off, stripped it back a little bit for all the individual strands. Actually, it works perfect, and it's multi-stranded in each one of those, so plenty of jumpers. Lay down some Tacky Flux, and there you can get it to sit. That is a lot of solder on that tip, FYI. And for the little solder that I was able to get on that pad, and what I'm trying to do with putting the wire on that, was not having it. So I got plan B. That wire's long enough, I'm actually going to go from the test point there, which is unaffected, and I'm going to run that up all the way to where resistor 1834 is. Now I have that tacky flux everywhere, including on my tweezers, so positioning this can be a challenge. Once again, trying to do this all under the microscope. So mainly I'm just trying to focus on that left side where that BO test point is. And if you get that pinned down, then it's a lot easier to work with. So ignore the fact that I'm currently running it over the rest of the circuit there. My recommendation, get another set of tweezers in there and really just pin it down. And lesson learned, there's a lot of solder on that tip, a lot more than I needed, so it just kind of makes it a little sloppy. Alright, so now that I got that point there fixed, that little bend to the left of R1835, pay attention to that. This wire is very soft, very pliable, very fragile. So try not to kink it as you're using it, as you're using your tweezers to pin it down and bend this to where you need it to go. Once again, be careful. So I'm just using 2 sets of tweezers, one to create a pivot and the other just to bend it where I need it to go. Apply some flux here. My goal is to try to, I wanted to tack that down with just a little bit of solder. As you recall, I couldn't get anything, any of the wire, but I was hoping that I'd be able to get some solder just to keep it in place and pin it. It's not working very well. The solder's sticking to the wire, but I cannot get that pad to take any of it. The solder I'm using here is 183C solder. It is leaded solder. As you can see, it's very, very soft. It's not the easiest to work with either. So at this point I realized that that pad is not going to take any of the solder. So I'm going to ignore it and go to the next step. Use one tweezers, create a little pivot, and redirect it. So my goal here is I'm going to actually go through that pad because I couldn't get that pad to take any solder either. And I'm going to go on the upstream side where resistor 1834 was. Reminder that that resistor is a 0 ohm resistor, so there's really no harm here. The only problem you might see is something caused this circuit to overheat, whether it was corrosion or buildup. Like I said, this is the air inlet side of the board, so you're going to see a lot of buildup here. You can see in the top right corner, a little bit of something on that board. I don't know. I think I tried cleaning that, and it didn't come off. Okay, so now I got that. I have the wire pinned over on the right side with some excess. Nothing with that. We'll clip that off later. But I am now bypassing 2 complete points. Even though the wire is soft, it'll stay in place. I mean, these go in the miner. That wire's not going to move. In some instances, I just take I've taken a little tiny pinhead piece of super glue just to keep it out of the way. Some of the repairs I've made. Since this is on the edge of the board and there's no components on the upper side of that, I'm not worried about it. So right now I'm trying to take the tweezers and I'm going to clip those ends. So I'm just propping them up a little bit so I can get my fine tip dikes in there and make the cut. Here I'm doing a test before I get too far into that. Just checking continuity from that test point, and it tested good. gosh, as you can see down there, even though I tried cleaning that earlier, getting in there, that corrosion on that resistor, there's just so much buildup. Once that alcohol dried, it just crusted up. Like I said, be careful in there. Sometimes I'll take the tweezers and just kind of scrape some off of that. Anywhere you get buildup on these components is a possibility of heat generation, and heat kills components. So once again here, I'm just doing an overall continuity check from the downstream side of resistor 2044 up to the upper right section. I'm having trouble getting good contact on that downstream side of that resistor. Alright, so get continuity, everything's good. The jumper is doing its job. And get the dikes in there, clip it, and clip that side. So now I'm going to do a check. Oh, there we go. Remember I told you to take a look at that point? So I put a crease in there that made that point weak. I did not put a whole lot of pressure on that, but like I said, this is very, very, very fine components, and that wire is pretty soft. If someone has, I just used what was on hand when I made these repairs, so I don't really feel the need to purchase additional wire or go through the trouble of actually trying to replace a track. So now the struggle. Now you see I clipped these, and now I'm trying to work with what I have, since I cut it since it's a little short. But when I made my bends earlier, I tried to actually mimic the path of the track, just for cleanliness purposes, aesthetics really. But here now I have to bypass and cut it a little short. So I gotta remove that little piece in there, put some flux, get my soldering iron tweezers, and that little cut off piece of wire that's on that BO test point. I gotta get that out of there. I was hoping I'd just be able to heat it up and have it stick to my iron. That didn't work. So now this is very, very fine. Trying to get in there and get a grasp at it. And there we go. I think I had my soldering iron in my other hand. I had to put that away. So obviously I'm trying to bend this straight. That's what I'm doing. Okay, so see where I'm pinching with my tweezers? Once again, I don't recommend doing that. Could do the exact same thing, create the same problem that I just had. So my recommendation is lay it on where you need to, get it somewhere close, and just pin it down, put some downward pressure, rather than try to grasp it and squeeze it and hold it in place and worry about putting another kink in it. Would that first wire have failed if I hadn't touched it? Probably not. It's probably good enough to do the job, and like I said, once this fix is done, just keep your hands off that board, which you really shouldn't be touching anything on the boards anyways, other than maybe heat sinks. But so I rerouted that, pushed it up out of the way. And that's good. Clean up, remove some of the excess flux, and we take the board back to the test station. Make my connections. And as you can see there, still has the 20 ASICs found from when I left it. Hit test, and let's see how our work was. Now we have 44 ASICs. Okay, so we know our test was good there, or our repair was good. So now that BO path has gone all the way to 44. So I repeat the same process before. I don't know if this is BO at this point. So once again, I'm going to, up in the chip 48, at the end of the board, I'm going to check my connection. As you can see on the Fluke, 1.829. Same as what I got before. So it tells me I still have an issue with that BO circuit somewhere. Now at this point, I'm just checking the repairs that we made. So during the first test, this was bad. 0.004. That's good. So now that I know that repair is good, we're going to go up to in between 44 and 45. So we're going to do the same thing as before and check this test point. Verify 44, which is good, 0.001 volts. And now I'm going to go in between 45 and 46 and check this BO test point. Get your negative probe on the test point there. Hit start. 1.825. Okay. So once again, that tells me that I am bad after the test point following 44. Okay, now we're back under the microscope, labeled 44 and 45, and pretty much identical. So once again, clean off whatever debris I can get there. Preparation for me to do some tests. And visually, this one looks a little bit better than the other one that we previously prepared. So I'm going to repeat the process. Once again, there's the flow path. And use my Fluke. I'm going to do some continuity checks. Try to identify what's actually bad with this. Visually, everything looks good. Check the downstream side of resistor 2080 to the test point. Verify continuity once again. That needle tip trying to get in there and get actual contact on that is pretty difficult. why even bother with checking the upstream side? I don't know. I guess just habit. In the future, I'll probably just bypass that. Following, I verify the resistor is good. So the upstream side of that resistor to the test point should be 33 ohms. And here I test it and verify that it is good, 33 ohms. Like I said, if you're testing this point, there's no point performing that first test and even struggling with trying to get that contact. So my recommendation is don't even do it. Alright, so now I verified that portion of the circuit is good. I have seen that resistor down there just off of that first chip be bad too, so don't get caught up just in this. Make sure you do check that resistor. I've made a repair before and then do the checks, and I realized that I do not have continuity all the way down through that resistor. So here from the test point through the resistor, I'm doing my checks. All right, I didn't get any continuity at that first check there, so here I'm checking this track, and that's good. Now I'm trying to check the upstream side of this resistor. And that's good as well. Once again, here you go. Don't even bother trying to get on that resistor. The next point there is that other pad I could be testing, so right underneath that. There you go. So don't even try making contact with that resistor if you know it's bad already. So once again, I verified this resistor is bad. We're going to zoom in, and we're going to do the same thing before. Pull that resistor off. Again, I dab some flux up there, and I dab some flux over on the test point. Not necessary, but I get in there to try to just kind of try to clean them up a little bit. So here, put some side pressure with your tweezers. Get in there. Soldering iron, temperature of 350 C, and just heat that solder and pop it off. Get your desoldering wick. Helpful tool for anybody out there that hasn't used this. So this soldering wick is pretty good. I've had some bad ones. If you do have some bad soldering wick that just does not seem to take the solder, for one, make sure your soldering iron is hot enough. And two, you can also put some rosin on the underside of that wick. It'll help soak up that solder a little bit. Right here, I'm just kind of dabbing it. I like to see if I get all the solder off. Another recommendation, try to get all the solder off, even though there might be some solder on there and you can work with it. You're going to be applying your solder, some new solder, so whatever solder Bitmain puts on here, I've had issues with working together with trying to get my solder to bind with their solder. So my recommendation is completely remove the solder. Get some alcohol, do some cleaning. And once again, I think I'm going to try to clean this up a little bit more. You can see the pad there on the upper side. Nope. No more cleaning. Might have tried to clean that a little bit more. Like I said, sometimes the solder that you have doesn't necessarily want to bind with the solder they have. I've had issues with that. I've noticed if I clean the pads better, then usually the solder takes right away. So as we did before, we had issues with that upper section. So right here, I'm just trying to put a jumper just using a solder. I'm not even going to bother with the wire this time. There's no point. Here, if you can create a solder bridge, it'll do just fine in replace of that resistor. Once again, the disclaimer, just because you make this repair doesn't mean you're going to solve this for long term. There may be another component that is causing excess current on this circuit, and that solder is not going to fail. The wire that we put in is not going to fail. However, it may just move to another component. You may end up burning up that chip. So if you feel so inclined, you can pop off a heat sink around there and actually visually look at the condition of the top of those ASICs. I'm not saying pull off the chip, but usually when you pull off a heat sink, you can take a look and see the condition of the ASIC, whether it's overheated or not. So there we go. We just made the jumper. As you notice, I went through it. I went through the point of that other pad where there's no resistor there. There's no harm there. It just adds a parallel connection to what was already there. And I should have just stuck with what I had there. I get kind of OCD about this stuff, so I went at it, and some of that solder stuck to the tip of my soldering iron. So I had to do a little bit of rework. But I'm happy with this. Do some cleanup. Just for my own reason. Originally I put some flux over there, so I have a little bit of solder on the tip of my soldering iron there. I just like to dab it to kind of refresh those test points. Like I said, I do some jabbing with it. There you go. Some of the boards don't even have solder on those test points, which is pretty nice. When you put your tip down, you actually just put it on just a regular pad. So much easier than trying to get that tip in there and bounce a tip on that rounded surface. Alright, so here we're zooming out, and I'm going to check the overall continuity of the repair that we just made. Here I come with the negative probe there and the positive. Verify over continuity, and I'm good. And we'll take the board back to the test fixture to verify our repair. Hit test, it starts counting up. As I mentioned before, it should stop about 5 or 6 if you have an issue. If it keeps going, it means you have 48 ASICs. You can verify, feel the board, and it'll start heating up. All right, then you want to turn off your test fixture first, and be sure to turn off the main power supply. Do not remove these leads without turning that off, otherwise you're going to arc there. So thank you very much for watching today. Once again, I'm Steve with YIHUA. If you enjoyed this video, please like or subscribe. Thank you.